Hey, it's Mr. Celentano, and this lesson is going to be on physical changes versus chemical changes, as well as physical properties versus chemical properties. So, new vocab to look for are just that, physical changes and chemical changes, and physical properties and chemical properties. So listen for those. They're all very different things. So firstly, we need to explain physical changes in terms of the matter we've been discussing so far. As it relates to that, physical changes are really what separates mixtures into pure substances. So you can kind of see in the diagram here, if you want to go from a mixture to a pure substance, you have to use a physical change, or vice versa if you want to go from a pure substance to a mixture. So, like we said, mixtures can be separated by using physical change. So what is the exact definition of physical change? Well, a physical change is a change that does not change the identity or chemical composition of the individual substances. So that's a fancy way of saying we're not changing the chemical makeup of the substance. Whatever we started with as that substance is going to be the same exact substance we finish with. So for example, if we have trail mix here, a physical change would be to simply pull the M&Ms out of the trail mix. We have now separated the M&Ms from it, and that's the simplest form of a physical change, really. The identity of the M&Ms has not changed. The chemical makeup of the M&Ms is still exactly what it was. We simply pulled them out of the mixture. Now, a little bit more complicated of an example is if you boil water. Now, liquid water, we know the formula for water is H2O, right? So in the liquid state, that's the formula for water. However, the formula for water does not change when we heat it up, when we boil it. It just becomes gaseous water. So then it becomes gaseous H2O. So, we have a guest. Say hi. Say hi to everybody. So we have liquid water and water vapor. They're still both H2O. And so we still have the same chemical that we originally started with. So we just simply change the state of it, but it's still H2O, and that's really important. Same thing if you were to change water into other phases of matter. It's still water, and so this is a physical change. So another example we would have is freezing. We could also talk about melting, evaporating, and dissolving. So this one tends to get people. Dissolving is also a physical change. So if I was to stir sugar into my tea, that sugar is technically still there. I didn't change the sugar. It's just dissolved now, right? So that's a physical change. You didn't change what makes up the sugar. It's still sugar in there. And if you crystallize something, that also counts as a physical change. So you're really just purifying it into a crystal, as what's shown in the image. So you're not making something new, essentially. Just another example, if we have an iced tea, we could separate the lemon and the iced tea simply by pulling them out, right? So that's the most basic form of physical change, separation. What if we had sand in our iced tea? So think about that. How could we get the sand out of our iced tea? Well, we could filter that. Filtration. So that's another form of physical change. After the filtering, the sand that was in the iced tea is still sand. We didn't change its identity at all. And the iced tea is still the same. So that's a physical change. What makes a chemical change very different is it's a change of one or more substances into other substances. So you're really making something new in this case. After a chemical change, you're usually left with a result that looks completely different. It's also referred to as a chemical reaction. So what we've heard of as chemical reactions are chemical changes. So common words that are associated with this: rotting, souring, burning, decay, transforming if something is digested or corroded. These are all examples of chemical changes. The other important thing is that chemical bonds, as shown here, are being broken and made. So if we look at this original compound coming in from the top left, that is combining with the compound in the bottom right, and the bond is being made, and then the green atom is breaking away. That bond is being broken. So that is what happens in a chemical reaction. You're actually changing the chemical composition of the matter that you started out with, and you're coming out with something completely new. The other important thing is that chemical changes on our diagram are the only way to go from elements to compounds, or vice versa. So you have to have a chemical change. You have to make or break bonds for that to happen. So here's a really complicated reaction, but it's actually one that you've seen before. This is actually the reaction of baking soda and vinegar. So if you look on the left, we have a couple of chemicals that we started out with, and then if you look on the right, we have entirely new chemicals being made, and so that's how you know it's a chemical reaction. And here's just what this looks like. So the carbon dioxide, if you look at our products, the carbon dioxide that's being produced, that's what's inflating the balloon. So that is a pretty common example of a chemical reaction. So a couple things to ask yourself if you're not sure if it's a physical reaction, a physical change or a chemical change. One is, did you make something new? So every time you look at a change, if it made a new substance, then it is absolutely a chemical reaction. If no new substance was made, if you ended up with the same substances you started out with, they just got moved around or changed in form, state of matter, then that's a physical change. Another really big one that helps a lot is to ask yourself, can I get it back? So if a chemical reaction has happened, you can't go backwards most of the time. And if a physical change has happened, you could get that back. So for example, if you burned wood, right? So burning wood counts as a chemical reaction because you're not going to unburn that wood. Or if you, for example, if you had ice melting, you could always refreeze that water, right? So you could get that back. This reaction over here is a famous reaction on the right over here that's called ferroserpent. You can look it up if you want to. You're definitely not getting that back. So that's like ridiculous. There's no way you're converting that back to what you started out with. So that is a chemical reaction that's happening on the right and a physical change that's happening on the left. So let's test what we know. So what do you think of perfume evaporating on your skin? Are we making something new? Well, no, we just changed the state of matter, right? We just became a gas, so that's a physical change. Butter melting, that's also a physical change. Wood rotting. Well, the rotten wood is now very different from the original wood, right? We're actually changing the chemical composition of that wood. It's now made of something entirely new, and so that's a chemical change. Charcoal heating a grill, you're not going to be able to convert that burned charcoal back into regular charcoal, right? So that is a chemical change. Autumn leaves changing color. You would not be able to change those leaves back. A hot glass cracking when placed in cold water. You're still left with the same glass that you started out with. It was a glass in the beginning and it's a glass now. So that's only a physical change. Melting copper metal. Still copper metal, right? We started with copper metal, we ended with copper metal. It's a physical change. Burning sugar. You can't unburn the sugar. So that's a chemical change. Mixing sugar and water. This is a tough one, but this is a physical change. Now think about why that is a physical change that you're mixing sugar and water. That's dissolving, right? So why is that? And then digesting food. I think we can all agree that once your food goes through your system, it's very different and a whole new substance than when it went in, right? So that's definitely a chemical change. So this is another very different word, very different phrase known as a physical property. This is very different from a physical change, but in some ways a little bit similar. So a physical property of a substance can be observed or measured without changing the substance's composition. So examples are color, odor, hardness, boiling point, melting point, solubility, and density. So what that means is that you can observe a physical property without the substance undergoing a reaction, basically. So for example, if we look at the chemical in this mortar and pestle right here, we can tell that it's a blue powder, right? So those are physical properties of it. We might be able to measure its mass. We might be able to tell whether it's soluble, how much will dissolve. We might be able to determine its density, or if it has a smell to it, right? Or if it has a hardness to it. So those are all physical properties. We could figure all those out without doing any chemical reaction, and that's why they're physical properties. A chemical property is very different. In order to know that, you have to actually change the composition. You have to actually go through and do a chemical change to see whether that works. So for example, if something is flammable, so in order to determine if this chemical was flammable, you'd have to actually try to light it on fire, right? And so that would change its identity after that. To determine if something rusts, if it decomposes, if it spoils, anytime you hear the term reacts with, you're going to know that's talking about a chemical property, because you can't know if it reacts with something without reacting it, right? And also whether it's combustible and flammable, so whether it can light on fire. So things like that, you're going to have, the only way to determine these properties, these chemical properties, is to actually undergo a chemical change. So let's test ourselves a little bit. If we look at mass, so we're trying to decide now whether these are chemical or physical properties. So is mass chemical or physical? Mass is physical because we can determine that without doing any reaction. Ability to oxidize, so rust, is that physical or chemical? Oxidizing or rusting is a chemical change, and so the ability to do that means it's a chemical property. Reacts with water, there's that reacts with, so that must be what type of property? Chemical. Reacts with base, so that must be chemical again. Volume, so in other words, how much space something is taking up. Can we determine that without a chemical reaction? Well, yeah, we can. We don't have to react anything with that to find out, and so that's a physical property. The color, you can determine the color just by looking at the substance, so that's a physical property. Reacts with acid, dead giveaway, that's going to be chemical. Solubility, take a minute to think, what do you think about this one? This one is going to be physical, because we can determine this property without undergoing a reaction. We're not changing the chemical identity of salt just by dissolving it, for example, in water. It's still salt in there, right? Odor, so we can tell that without doing a reaction. Luster, does something shine? We can tell that without a reaction. Flammability, it's a chemical property because we have to actually undergo a reaction to determine whether it would happen. Melting point, so this is the temperature at which something would melt. This is a tough one. This is a physical property because even when you melt it, you're not changing its identity, right? If we melt ice, it's still H2O, so that's very important. And boiling point, same principle. If we boil water, it's still H2O, and so the temperature at which it boils is a physical property. We didn't change water in order to figure out that property. And whether it's stable chemically, well, that's a chemical property. Okay, so quick vocab rehash. A change that does not affect the chemical composition, that's a physical change. A change that causes a chemical to convert to a new chemical, that is a chemical change. So you're making something new. A property that can only be observed by a chemical reaction is a chemical property. And a property that can be determined without a chemical reaction, that is a physical property. So, thank you for watching, and remember, chemistry is everywhere.